Welcome back. We have one more video where we're talking about simplifying complex fractions. We just did this example here and we didn't consider any domain restrictions because I have an interaction of variables and we haven't been talking about that yet. But when I look at this example, I'm asked to simplify 1 plus 1 over x all over 1 over x squared minus 1. So the way we worked through this, we found the least common denominator of the numerator. And we found that to be here, that's just x. The denominator here is 1, the denominator there is x. The least common denominator of the denominator is, I have an x squared and a 1. So now the least common denominator overall is just going to be x squared. So I'm finding the least common denominator of those two things. So I'm going to take my 1 plus 1 over x over 1 over x squared minus 1, and I am going to multiply this by x squared over x squared. This is a convenient value of 1, and then this is going to get distributed into my numerator and my denominator. If we remember back to what we were doing before I go ahead and step through this, I need to consider my least common denominator. X squared is in the denominator. So I'm going to have a domain restriction that x cannot be equal to 0, because if x is equal to 0, I violate my division by 0 rule both here and here. So we have a domain restriction that can't be. All right, so now that I have identified a domain restriction, I'm going to keep going. So I distribute x squared in, and that gives me x squared plus x. X squared times 1 over x is just going to be x. Divided by x squared times 1 over x squared will be 1. X squared times negative 1 will be minus x squared. Now I want to go through and factor and simplify. So let's fully factor. So when I fully factor the numerator, I can pull out a common x, giving me x plus 1 in the numerator. X times x plus 1. 1 minus x squared, this is going to be the difference of squares. 1 is a perfect square, x squared is a perfect square. So this becomes 1 minus x times 1 plus x. So now I have another denominator, and that denominator is going to give me more domain restrictions. If x is equal to 1 or negative 1, I end up with a denominator of 0. So the values of 1 and negative 1 are both restricted from my domain, as well as 0. Okay, so then I can cancel out things that are in common, and this simplifies down to be x over 1 minus x with the domain restrictions that x cannot be equal to 0, 1, or negative 1.